So for the rest of Module 6, instead of area, we're going to talk about volume. Now, volume has to do with three-dimensional or 3D shapes, which we saw a little bit of earlier this year. So let's review some of the shapes we saw. Right here, we have what's called a rectangular prism. That's the most simple 3D shape there is. It's basically any box. You have all perfectly straight edges, all perfectly flat faces. Every face is a rectangle. And you have three dimensions, length, width, and height. But there are other prisms. So a prism, if you remember, can actually have any polygon for its bases. So right here we have an example of a triangular prism. Triangular because the bases are triangles. So when I say the bases, every prism has these two shapes. Like you have this triangle here in the front and this triangle here in the back. Those are what we call the bases. They're going to be two congruent shapes that are parallel, and they're connected by rectangles. So this is what we call a triangular prism. Triangles on the bases, always connected by rectangles. Now our new shape, the one we didn't see the first time through, is called a pyramid. Now a pyramid is kind of like a prism, but instead of having two bases, we're going to take one of the bases and we're just going to turn it into a point. So right here, this is an example of a rectangular pyramid. So just like a prism, a pyramid can have any polygon for its base. This one right here has a rectangle on the bottom, and instead of a prism where it has a rectangle on bottom and the same rectangle on top, what you have is a rectangle on the bottom. It all meets at one point on the top, and instead of rectangles going up to the top, you have triangles that meet at that one point. So this has a rectangle or possibly a square on the bottom, and it has four triangles, one coming from each edge of that base, all meeting up at a point up top. So our main topic for today, and actually for the rest of Module 6, is volume. Volume is the amount of space inside of a three-dimensional object. So a good word problem is like, okay, you got this shape, whatever it is, a cylinder, a cone, a pyramid, a prism, whatever, and maybe you're pouring water into it. How much water does it take to fill it up? That's a volume question. How much space is inside the shape? Now, remember we said when you're measuring a length, you have units. You have like inches or feet or meters. And what we said earlier is when you're measuring area, it's square units, square inches, square feet, whatever. Well, volume is measured in cubic units, or it's that unit to the third power, basically. So the unit you see on the screen right now, that would be cubic centimeters. And that would be if you're measuring volume where each of the measurements in the picture is measured in centimeters. Now, this is a formula we already learned this year, the first time through. Volume of a prism is volume equals base times height, where it's a capital B, not a lowercase b. When we did area of a parallelogram earlier, area was base times height, and the base was just a line. This time, the base is an actual two-dimensional shape. So that capital B is actually an area problem. We're going to do an area problem right here, find the area of that base, and then multiply it by the height. Now for a rectangular prism, it's actually very similar because the area of a rectangle is just length times width. So this length times width is the area of the base. So for a rectangular prism or a box, instead of thinking of it as capital B times H, I always think of it as just length times width times height. There's three numbers, two across the bottom and one for height. If you multiply those three numbers together, you're going to have the volume. So for our first example, let's make it a nice easy one. What we have is a rectangular prism or a box. Now, there's two ways to think about this problem. I said the easier way is to just do volume of a box or a rectangular prism is length times width times height. Now those are those three numbers. It doesn't matter which one is which. You have a 4 inches, a 10 inches, and a 3 inches. Those are the three numbers in any order. It's not like, okay, one of them has to be length and one of them has to be height. It doesn't matter. you multiply them together. So let's do volume equals 10 times 3 times 4. If you multiply it all together, you get 120. So the answer is 120. Now, since I'm measuring each length in inches, and this is volume, my answer would be 120 cubic inches, or inches to the third power. Now, remember when I said there's two ways to think about this question? The other way to think about it is to say the volume of any prism, not just a rectangular prism, is capital B times H. And then you look at it and you say, okay, well the base here is a rectangle. And the area of a rectangle is length times width. So I say, okay, the area of that rectangle is 10 times 3. And that's 30. So my volume would be 30 times the height, which is 4. And you get 120 cubic inches that way. So there's two ways of thinking about it. You're doing the actually the same work, because this 30 here just came from doing the 10 times 3. So the length times width times height is kind of a shortcut for a box or for a rectangular prism. But for any prism at all, doesn't matter what the base is, you can always use that formula I did second, volume equals capital B times H. And let's do one of those. So for our second example, let's find the volume of this triangular prism. See, now I can't do length times width times height. This is not a box. This is a weird triangle, kind of extended triangle shape, or what we call a triangular prism. But I look at it and I say, okay, it's a prism. There's definitely a triangle for the base. I can't do length times width times height. That's only for the rectangular prism. So let's do volume equals capital B times H. And I say I need to find the area of the base. Now the base is this triangle right here. So I think, okay, what's the area of a triangle? Well, the area of the triangle is 1/2 base times height. And that's lowercase b. I know it's kind of weird to have two different bases in this problem. But if I'm looking at an area question, area of a triangle is always 1/2 base times height. Well, in this triangle, the base is 8 feet. And the height is 7 feet. So the area of this triangle is 1/2 times 8 times 7, which would be 4 times 7 is 28. So now I go back here to my volume question and I say, okay, so capital B, the area of the base is 28. All I have to do is multiply it times the height. Well, the height, usually when we think of height, we think of up and down, but this prism has been kind of tipped over on its side. The height is the distance between the two bases, or the distance between the two triangles, which is this 10 feet right here. So my answer is going to be 28 times 10, or our volume is 280. And then for units, I look back at the picture, I was measuring feet this time. So this is going to be in cubic feet, or feet to the third power. So final answer is volume equals 280 cubic feet. The last thing I want to do today is talk about volume of a pyramid. Okay, so here's a nice neat trick. Once you know volume of a prism, which we just did, the volume of a pyramid that has the exact same base is going to be exactly 1/3 the volume of the prism. So what you want to do is when you see a pyramid volume question, look at the base, say, okay, if this was not a pyramid, if this was a prism, what would the volume be? And I would do volume equals capital B times H. All you have to do at the end is take that answer and divide it by 3, or multiply by 1/3. I did say in the notes here, make sure you use the height for H and not the slant height, because all of a sudden that's one of the differences. In a prism, everything's pretty much up and down. But in a pyramid, it goes diagonally. And if I give you this measurement here, that's not the height. This is the height. So this will be our last example today. Find the volume of the pyramid. Now I did give you the height this time. In fact, it says right in the question, each equals 9 centimeters. And it's got that arrow pointing to the perfectly vertical line. So 9 is definitely the height. Now what I'm going to do is I'm going to say, let's do this. Let's pretend like this wasn't a pyramid. Let's pretend like this was a prism and just do the same question that we just did, but put a 1/3 in front of it. So I look at the base. The base is a square, 8 by 8. So what I would do, I would say if this was a prism instead of a pyramid with a square for the base, what I would probably do for the volume is just do length times width times height. Or like I said earlier in our first example, you could do capital B times H, it's the same thing. But then I say, well, wait a minute, this is not a pyramid, or this is not a prism, this is a pyramid. So what I'm going to do is I'm just going to put a 1/3 in front of it. And that 1/3 that I added in red is the only difference between doing this question for a pyramid and a prism. So let's see what it comes out to. Volume ends up being 1/3 times 8 times 8 times 9, which would be, let's see, 64 times 3, 50, 180. I think it's 192. And that would be in cubic centimeters. So the way we present these two shapes is, let's take most of the day, like we did in the notes today, and really understand how to find the volume of any prism. And then let's just say, well, what if it was a pyramid instead of a prism? Do the same question, but divide that answer by 3 or multiply by 1/3, and you'll have that answer.